right, guys, so everybody should have a Post-it note, because I realized as I was going through my notes that there's something in mine that, for whatever reason, got accidentally deleted out of yours, and there's not really enough room in the notes packet to just add it off to the side, because we're getting ready to start applications. So on your Post-it note, this is what I want you to put there. We've talked about finding component form if we have the initial point and the terminal point. And then once we put it into component form, we can find the magnitude, we can find the direction. If I'm told the magnitude and the direction, sometimes I need to know the component form. The way I do that, if I know the magnitude and the direction, this is what you're writing on the Post-it note, yes. Because this is not in the notes packet, but it was supposed to be, and there's not really any extra space in there. So the way I find the x part of the component form is the magnitude of the vector times cosine of the angle. And the way I find the y part of the component form is the magnitude of the vector times the sine of the angle.
The two lines, that's magnitude?
That is magnitude, yes. And while you guys are jotting that down, we can go ahead and talk about why this is. On your unit circle, the x part of the ordered pair, does that go with your sine or your cosine? Cosine. The y part of the ordered pair is your sine value. What's the radius on a unit circle? 1. So all this is doing is saying to find the x part and the y part, I'm still going to do cosine for the x, I'm going to do sine for the y, but then I'm going to multiply it by the magnitude, which would be the radius of this bigger circle. Does that make sense? A little bit? Okay. I want to practice with these 3 examples down below, writing it in component form. So if I know the magnitude is 6, and the angle is 53 degrees. The x part of my component form would be 6 cosine 53 degrees. And the y part of my component form would be 6 sine of 53 degrees. If I pop those in my calculator, I can see about where they are, but I'm going to have to round them. So unless they're just asking me for component form, I would leave it in its exact form so that I can use it in a problem. Does anybody want to help me write component form for part B? Perfect. That's all there is to writing my component form if I know the magnitude already and I know the direction already. Let's knock this last one out. How would I write part C in component form? Perfect. That's exactly correct. We're going to use this idea right here in all of our story problems that we're going to be working on. I truly thought we would get all the way through all of them today. depending on how much discussion we have to have, which it's fine to have, because I want to make sure we understand each piece. We might not get through all of them today. We would wrap those up at the beginning of class tomorrow. For anybody who's planning on taking their quiz tomorrow, we're going to go through several story problems before you would even begin that. So you would still have a chance to go over those pieces and understand a little bit better. Okay? I prefer doing the story problems that have bearings and stuff with vectors than the way we've done them up to now. And hopefully I'll be able to demonstrate why I prefer it with vectors. There's a lot less like guessing or is my picture exactly right? Yes, ma'am.
Just to clarify, the quiz tomorrow is over everything else.
8-3, yes. Yep, just that packet. And the quiz is on Monday. It's for people that already know they're not going to be here on Monday that elect to do it tomorrow. Yes. Was there another question?
So if you, 2 questions. What if you're not here tomorrow or Monday?
Then I guess it would be Tuesday, but you're going to miss what we're doing in class unless you come in during your 5th period study time.
Okay, so you can take the quiz during 5th period, right?
Yes, I can do it during your 5th period study time.
Okay, and then also, any story problem on the test, we can use vectors instead of using law of sine and cosine. I mean,
If you have enough information that vectors would work, yes. Yes. The only time that you would have to use a very specific method, like, oh, I can choose from this or this or this, is if I say specifically, like, use law of sines or use law of cosines. Other than that, it's going to be you figuring out what information do I have, what tools do I have to be able to answer the question, what makes the most sense here. Yes. All right. We're going to look at that first story problem that's down at the bottom of the 3rd page. The reason I like doing story problems with vectors, especially when they give me bearings. You know how we've had like no end of trouble with our bearings? Or at least I have on some of them. Like, wait, which way are we facing? What are we doing? Once I get my vectors written, I can add my vectors together, and that will tell me everything I need to know about the 3rd side. It will tell me the angle that it's at, so I can use that to write my bearing for my answer. And the magnitude will give me the distance, or maybe it's a speed problem. Magnitude will tell me the speed. Anything that is a scalar value has a value but does not have a direction associated with it. I can use it on all these types of problems. All right, so I'm going to draw a picture for this one, and we're going to write the vectors that go with each piece. All right? It says Taylor walks 45 degrees north of west for 1,000 feet. So because of the end of the question, I'm assuming that she starts off from her house. Because if she doesn't, I have no idea where her house is, and I can't answer the question. She walks 45 degrees north of west. That's a weird way to say what? Northwest. So she takes off in this direction right here. Not a very straight line, but it'll work. How far did she go? 1,000 feet. And when it says north of west, north of something means I would have to start from somewhere and then go to the north, right? North of this. So they're telling me that this angle right here is 45 degrees. That is north or above that west line. Just this information that I'm circling, the 1,000 feet. Is that a magnitude or is that a direction? 1,000 feet. That's magnitude. What about the 45 degrees north of west? That's the direction. When I go to write a vector, I need to enter my angles like unit circle angles. So I need to be measuring them from that positive x-axis. So if I'm going to use this in my problem, I don't care about the 45 degrees. I need this angle. What would this angle be if you know that little bit there is 45 degrees? 135 degrees. So I'm going to write a vector for this right here. We're going to write it in component form, just like we practiced and I had you write down on your Post-it note. What's our magnitude? 1,000. And then to get the x part of the component, I do 1,000 and then which trig function? Cosine of, this would be 135, remember, because for sine and cosine I have to use my unit circle angles. They don't have to be unit circle angles, but I have to measure them from the positive x-axis over. So 1,000 cosine 135. How would I get the other part of this vector? Yep, 1,000 sine of 135. You guys okay with that vector? That describes the first little leg of her journey. What did she do after that? She went due. What does due north mean?
Straight up.
Straight up. So I'm going like this for 200 feet. Is 200 feet direction or magnitude? Magnitude. I need to be able to get a direction. Do I have anything that's telling me a direction? Due north. But I have to describe my direction as an angle. Straight up would be 90. Yes, here's due north. And I always need to be measuring that from the positive x-axis. So that's going to be 90 degrees. So let's write the component form for that vector. What's this one going to look like? Magnitude 200. Cosine of 90 degrees. 200 sine of 90 degrees. How are we doing so far with our component form for the 2 legs of her trip? Yes, sir. 90. Due north. If I go like this, now think about your unit circle. What is this in degrees on your unit circle? That's the ordered pair. How many degrees? 90. She went northwest, but then she walked due north. That's straight up. So she walked northwest for a while, then she stopped. Then she walked straight up. What'd you say?
90.
Yeah, anytime you're going straight north, it's 90 degrees.
So regardless of what happened first, it's just gonna...
Yes. We are not paying any attention to the first leg of her journey.
Okay.
We're writing a vector here that's just for the second part of her trip where it says then she turned and she went. Here's a vector that tells me about what she did the second part. Yes.
So anytime you start a new leg, you can start a new compass.
Yes.
So it says
Yes. Anytime you start, anytime it's turn and do this now, you're doing a whole new compass rose and you're going to write that angle. Yes. Does that clarify? Okay. So far, so good with our 2 vectors now. You guys comfortable with how we got the component form? Okay. The question that they're asking me to answer is what? How far What are they asking me for if they want to know how far, and I'm talking about vectors? Distance, which would be magnitude. And at what angle? What are they asking me to find if they say at what angle? Direction. Well, funny thing, we practiced finding magnitude and direction, didn't we? So we're going to find magnitude and direction from her house. So Taylor's off doing whatever. Mom is back at the house. So from the house, how would we describe the distance that Taylor is and the direction that Mom would need to go to get to her? If it says from this, that's where we're standing to find our angle and to find our direction, or to find our distance, okay? So visually, what we're going to be finding is this third side of the triangle over here. I need to know how far, and I need to know what kind of a bearing it would be. Just based on the picture alone, I'm guessing that Taylor is in what quadrant? First, second, third, or fourth? I'm pretty sure it's second quadrant. I will show you how we can know for certain, even if, like me, you draw bad pictures sometimes. When we use vectors, I can always be 100% sure of what quadrant I'm in. We are going to add these two vectors together. That will give me that third side. Do you remember how to add vectors? X plus X, Y plus Y. I'm curious, though, as we do this, do you know what the cosine of 90 degrees is? 0, right? So this is really 200 times 0, which means that's just what? 0. So I'm doing 1,000 cosine 135 plus 0, which would just give me what? 1,000 cosine of 135. A lot of times I can't actually add them together like this. I just have to leave them in their two parts because they're not like terms and it's not a unit circle thing. It's okay if you have to leave them as this plus this for the x part. Do you know what the sine of 90 is? 1. So I've got 200 times 1, which would just be 200. So what's the y part of my component then? Yes, 1,000 sine 135 plus 200. So far, so good? All right. We're going to use this for the magnitude and direction. We're going to keep it in its exact form. But I'm going to push pause real quick, and I'm going to make sure that I know for certain what quad I'm in. So I'm going to take each part of this component form and I'm going to pop it into my calculator. Because when we go to find direction, we use what function? Tangent. Inverse tangent can only find me angles in which quads? 1 and 4. So if I'm in quad 2 or 3, I need to know because I'm going to have to add 180 onto it. So this is just a little aside. I'm not going to use these numbers to find the magnitude or the direction. This is just to tell me to confirm what quad I'm in. If you do 1,000 cosine 135, this is about how big? You said negative what?
707.
Yes, negative 707 ... I really just want to know if it's positive or negative, right? because I'm just trying to figure out what quad I'm in. I know I'm not using these numbers. I need the exact values for everything else. What about this part, the y part? About 907. So if I have an x that's negative and a y that's positive, yeah, we're in quad 2. And now I know that for a fact. So I know when I give my direction at the end, if I'm in quad 2, which ways do I have to head?
South and east. Well,
To end.
from there.
Remember, we're at the house,
Then
north and west. To get into quad 2, we would have to head north and west. All right, let's find our magnitude. How do we find magnitude again? We're going to square some stuff.
You want to square 1,000?
Yes, square root of x squared plus y squared. So we're going to do 1,000 cosine 135, and we're going to square it. Stop for a minute and pop that in your calculators. Please make sure, because calculators are finicky little creatures, after you hit the cosine button, your calculator opens up parentheses. If you close it and then do the squared, you're telling it that you want to square just the cosine, not the cosine of 1,000. You're going to have to double close these parentheses here. Just to make sure we're all on the same page. Tell me what you get when you do this. I got like 500,000 here. Is that right? Okay. I'm stopping along the way to make sure that we got the right values. Plus, what's the other thing that I'm going to need to square? 1,000 sine. Be careful here because your calculator opens up those parentheses for you. You got to close them before you do the plus 200, or else it thinks that you want to do an angle that is 135 plus 200. And then square it. This one doesn't come out so pretty, but go ahead and tell me what you get when you do that. You said 822, 842, something, something. Okay. So you need to add those two together and then do what? Square root the whole dang thing. Please make sure that you're grabbing your calculator and getting these values along with us. Because fourth period today, like, we got the big idea, but we could not manage to get the calculators to give us the right numbers, and so that was causing a huge breakdown. Yes, ma'am?
We need to do that, or we can just put it all together in the calculator.
If you can see it all on the screen without having to scroll over, then you can do it all in at once. The issue that I saw earlier today happening when they put it all in at once was that we weren't getting all of our sets of parentheses closed correctly. So, short answer, yes. Longer answer, yes, be super careful. And we're using this to find our magnitude, which is going to be my distance. So after you square root that whole hot mess, what do we get? 1,150 point. Yep, 150. Or 149, or I'm not going to get picky about the last digit. Would we need units on that? Feet. All right. How are we feeling about the magnitude part? Reasonable? Okay. What do I still need? Still need direction. What do we use to find direction? Inverse tangent, yes. Do we need to add 180 onto the end of this one? Yes, why?
Because it's necessary for
It's in the second quadrant. So theta is equal to inverse tangent y over x, right? What is the y component of my vector? Yes, 1,000 sine 135 plus 200. That all goes up in my numerator. Sorry, I'm just trying to fit everything on my screen here. What goes down to my denominator? 1,000 cosine 135. Do just the inverse tangent part on your calculator before you do the plus 180. Again, I just want to make sure that we're getting the same values out of our calculators here. That's after you added the 180, right?
Yes.
Do you remember what you got before you added the 180? Negative 52.062 degrees. And then we add the 180.
127.937.
127.9. You said 37? So this thing actually rounded up there. I'm not getting picky about that very last digit.
I just put it all together.
Yeah. Yeah, if you put it all together in your calculator, totally fine. I just, after what happened fourth period, I'm like stopping every couple seconds to make sure that it's going in the calculator correctly and that we're all able to get the right answer back out. Is 127 degrees in quad 2? Mm-hmm. So I need to figure out how to write that now as a bearing. 127 degrees is going to be about right here, right? Subtract 90 from it, because for my bearing angle, this is the angle that I want. So I'm going to minus 90 from that to get what? Yep. So 37.937 degrees, and now I need directions. If I'm in quad 2, I have to go north and west. Because remember, we're doing this from the house. From the house to get to Taylor, we're going to have to go to the north and to the west. So far, so good? Let's flip the page and look at another one. You are more than welcome to draw pictures if they help you understand it better. But I don't need a picture if I'm using component form for my vectors. Let's see if we can practice it that way. A boat leaves port at an angle of north 30 degrees west for 15 nautical miles, period. Am I given a direction and magnitude there? What is my magnitude? 15. So here's my magnitude. And do I have a direction? What did they tell me? North 30 degrees west. But I can't use 30 degrees because they're measuring from north-south. And my sine, cosine, and tangent, I have to have things in standard position, right? Would it be what? Yes, it would be. Here's north 30 degrees west. That full angle is what I need. So we're going to use 120 degrees in our component form. So help me write the vector for the first sentence. Fifteen cos 120. 15 sine 120. Perfect. So there's the first part of this boat's trip. Captain then changes directions. That means new vector. What do we know about this new vector? North 20 degrees east. Is that magnitude or direction? That's direction. So I'm going to need to figure out what that is in standard position, right? All right, I'm going to draw a little picture, just like I did for the other one. What quadrant is north 20 degrees east in? First quadrant. It'd be like this, right? So what would the standard position angle be? 70. I need this angle right here because I always need it in standard position. Did you have a question?
Yeah.
Mm-hmm.
Why in this problem the triangle is close to the north and then another one was close to the west?
One more time.
Like right now, the triangle you have it more close to the north, but
Mhm.
another problem was close to the west. Like,
It has to do with
yeah.
what the angle is, with how many degrees it is.
Okay.
Yep. Because when they start with north, and then they tell me how far to tip, either to the left or to the right, depending on whether I'm talking about east or west.
Oh.
So something like north 80 degrees west. Well, north 80 degrees west puts me almost all the way west. Because I start from north and then I tip 80 degrees this way. Okay? Do I have a magnitude that goes with this next bit? 10 miles. Here's my magnitude. All right, so our direction, we said we have to use 70 degrees because that's what north 20 degrees east is when I'm talking standard position. Help me write this vector then. Ten sine 70, yes. So far, so good? I want to determine the distance and direction traveled from port. Port is where they originally started from, right? So port is going to be my origin. So if I can add these two vectors together, that will give me the terminal point for this vector from port. Port being my origin, and then this is going to go straight to where they are in the water. That's what we're finding. We're going to add these two together. Is 70 degrees a unit circle angle? No. And even though 120 is, I want to practice right now what it would look like if neither one of these are unit circle angles. Like, how do we write that? How do we do it? So I'm just going to add these two together. I'm going to leave them as their individual pieces. I cannot combine them together. So it becomes 15 cosine 120 plus 10 cosine 70. That's the x part of my component form. For the y part, 15 sine 120 plus 10 sine 70. That's what I'm going to use for my magnitude and my direction. Let's pop it in our calculators real quick, though, so that I know what quad we're in, so that we know whether or not we need to add 180 onto it. This is what we're going to use for magnitude and direction, though. The x part of the component form. About -4. All I really care about is it positive or negative? I do not need to write the whole thing out. I'm just trying to figure out what quad I'm in. What about our sine values? +9 something. Cool. So I'm in quad 2. For the direction, will I need to add 180? Yes. Why don't we go ahead and find the direction part first, and then we'll find our magnitude. What operation do I need to use to find direction? Inverse tangent. So theta is equal to inverse tangent. I put the entire y part in the numerator and the entire x part in the denominator. Yes, ma'am. I thought that's what somebody had told me. Oh, 22, sorry. I literally was just going off of what I heard. There we go. Yeah, now I see it. I hadn't even looked at my note sheet. I was just like, I remember it's positive. We're good. Not trying to confuse anybody. All right, so y part goes to my numerator. What do I put in the denominator? The x part. And you said I do or do not need to add 180? I do. Because we are in quad 2. So theta is right about how big? Perfect. So that's theta. I know they want me to give this answer back as a bearing, though, because they gave me the angles as bearings. So I'm thinking about just a compass rose. We're in quad 2, right? 100 degrees is like right here. So how will I get my bearing angle just this little bit? Subtract 90 from it. So I'm going to get 10.328 degrees. This is my bearing angle. What directions do we need to travel to get to quad 2? North and west. So it's going to be north 10.328 degrees west. Remember, tangent finds my standard position angle, but then I have to figure out how to write that as a bearing from a north-south line. Mm-hmm. So if we're in the third quadrant, it would have to be bigger than 180. And then to find it in the third quadrant, I would do, because I always want to go from a north-south line, so I would do 270 minus the angle that they gave me. 270 because I would have to go all the way down to the south line.
So we'll be doing a reverse tangent until you do a quadrant.
Yes, inverse tangent will tell you what quad you're in, but only if you already know whether it's like it's 2 or 3. But then yes, you should get the same quadrant that we got from the ordered pair. The problem with just doing inverse tangent to figure out what quad you're in is inverse tangent can only tell me 1 and 4. All right, let's do magnitude real quick, and then we will stop here for today. How do I find my magnitude again? Yep. You're going to have to square the x part. Please, 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 please be careful. Anytime you have an angle, you got to put parentheses around it in your calculator, or it will jack it up. I need more room for this. So you square the x part. You also have to square the y part. I'm trying to free up some space on my screen for that. There we go. Not done. Just trying to make room. Because I know I'm going to have to square root this whole thing. I'm going to add this to the square of the y part. Please be super careful with your parentheses, especially around your angles, because it will royally throw your answers off. You got how much? I got 22.756 as well. What kind of units would we need with our magnitude? Miles.
Nautical miles.
Nautical miles. All right, guys. We're going to do a couple more practice problems with story problems at the beginning of class tomorrow. If you're planning on taking the quiz tomorrow, because you know you won't be here on Monday, you still get story time problem with us first before you take your quiz.